Hi guys, so I'm going to do another subliminal advertising. Lifesavers. What's that got to do with this video? Well, we've got a lifesaver right here in orange behind me. So we're going to look at radicals that have indices that can be different sizes here. But what happens if the power inside the radical, here's a good example, the power inside the radical in the exponent is the same as the index? Well, if n, which is going to be the index and the power, is an even positive integer, then the nth root of a to the n is going to be the absolute value of n. And if n is an odd positive integer greater than 1, then the nth root of a to the n is going to be just a, or the radicand. What on earth is that talking about? Well, let me demonstrate with these guys, okay? Well, actually, what I usually do, if you understood that, then go ahead and try these, 5, 6, 7 problems and see if you can get them. So it's a challenge for you. I do this with my regular classes, and over time, I've had maybe 2 students who have gotten them all right. Okay, so let's see how you guys do. There's a couple tricky ones in there. If you don't understand, then just work with me on this, okay? If you think you got them, then pause the video and see if you can work these out, and then unpause and see if you got it. But if you didn't, just follow along here. So we've got the square root, right? So it's a little index of 2 there, of negative 5 squared. So let me show the long way of what's going on here, okay? So this is going to be an even root, so the answer is going to be 5, as it turns out. But why? Well, if you look at this, we're talking about taking a negative 5 times a negative 5 inside that square root, right? And that is the square root of 25, which is 5. Right? So your answer is 5. So I could have skipped these 2 intermediate steps by using this little property, this little lifesaver here, by showing that we've got an even n right here and here. So that means whatever our a value is, it's going to be positive no matter what. And that's what we're seeing happen there, okay? So that's what they're trying to illustrate by this first thing here. This guy here, I'm not sure why I put this in here, but hopefully you're figuring this out. 6 divided by 2, you do that little shortcut I showed in a previous video, is 3. So our answer here is going to be x cubed. So I didn't end up using either of these properties on this guy, but I will on this one. Let's see how you did. The 4th root of x plus 6 to the 4th, you think it would be just x plus 6, right? It's not the answer. Notice I have not boxed my answer in there yet. Because if there's a variable involved, then we're going to have to throw in some absolute values here. It'll be the absolute value of x plus 6, right? Because suppose that my x was a negative 9, excuse me. Negative 9 plus 6 would be a negative 3. And if I did not have my absolute values here, then I would have said, okay, negative 9 plus 6, like I said, it's a negative 3. We would have come out with a negative value as a result, and that would have been incorrect. So that's why if you have a variable in there, and we're talking an even index and an even power of the same caliber, same n, and they're both even, and we're dealing with variables, you've got to have absolute values there. Now let's look at this second one. So I've got an odd index, odd power, they're both the same, bigger than 1. My answer is going to be a negative 3. Okay, it's not going to be the absolute value of that. So if your index and your power are the same and they're odd, you don't need the absolute values there. But if they're even, you do. That's basically what to take away from this. But why did this one work the way it did? Well, let's see for a second. That's a negative 3 times a negative 3 times a negative 3. Right? That's 3 negatives. Negative times a negative is a positive, and that positive times the last negative will make it go back to negative. So that's why. As for this guy, hopefully you're figuring this out by now. Your answer here, the 5th root of 7x minus 1, quantity to the 5th, is just 7x minus 1. You do not need absolute values on that one because I've got an odd index, okay? That's what's making this guy different from this one, it's fourth root. Let's see how you did with the square root of 36x squared. Well, the square root of 36 is 6. The square root of x squared is really absolute value of x there. Now, having said that, if you were taking my class and you forgot to put the absolute value of x there, I probably would let that one go. A lot of textbooks forget that. I don't know why, to be honest. There is a bit of a disconnect there. So if you forget the absolute value in situations like this or this, I don't know how stingy I would be about docking you. Now, if you're not my student and you've got another teacher that's teaching you this, they may ding you on this. I don't know. It depends on how strict people are. And if you're taking a higher level math class, you might need to take that into consideration as well because there are other factors involved there. Talking about proofs and things like that. So you got to really watch for those sorts of things, okay? All right, let's see how you did on this last one. The square root of x squared plus 6x plus 9. What? I don't know what's going on. Now, I don't know if you picked up on this, but that is a perfect square trinomial. That's really the square root of x plus 3 quantities squared there, right? So what's the answer? Hopefully you got it now. It's going to be the absolute value of x plus 3. Boom. Got it. All right. Hopefully that illuminates some things for you there. How'd you guys do? Hopefully you got it.